So for example, number course 2, prerequisite is 1, 0. Before you can take course 1, you need to do course 0. So you start out with 0 and then you come 1. There's more complex ones, so maybe we can use this as an example here. So 1, 0, so we have 4 number of courses, so probably write this down. 1 depends on 0. 2 depends on 0. 2 depends on 0. 3 depends on 1. 3 depends on 1. 3 depends on 2. 3 depends on 2. Okay. That's basically you have to take course 0 first. And then course 1 or 2. And then last one is 3. Right. For you to take course 1, you have to do course 0 first. So you start out with course 0, then 1, 2, or the other answer is 0, 2, 1. So basically the output should be 3, 2, 1. So it's more like if I'm gonna write it like a tree, you have something like 3 here, and then you have 1 here, and then you have 2, and both of them goes to 0, 0, right? 0 here, 0 here. So when you do a depth first search, you go here and you see a 0, then you move up, right? You finish all this one first and then you move up. So it's more like a post thing where you finish all the child first before you move up the rank. So it's like a depth first search reversal, but you have to finish all the child nodes before you move go back up. Yeah, so that's how you basically solve this problem. Now, is it possible? There's a case wherein there's a cyclic, wherein that one is you have to track it. Cyclic means 0 goes back to 2. And that is something you have to take note of. Like if there's a cyclic, you basically should say it's impossible to finish all this course and return an empty array. Yeah. Okay, so I guess we could start first with a depth first search in Golang. So how do you do a DFS in Golang? So, right. But in order for you to do that, because the representation of the prerequisite is AB, right? AB means 0 and 1. So what you want is like an adjacency matrix wherein node 1 is your like a hash map where you could just find the nodes and then find all of its child nodes. So for example, 3, right? 3. But what are the child of 3? So for 3, I could go to 1, then I could go to 2. Right. For node 2, where could I go? I could go to 0. For node 1, I could go to 0. For node to 0, it's nil. So basically, yeah, nil. So this is your adjacency magic, and all you need to do is basically go through all of this, like do a DFS, and you just have some tracker, like a variable to say if you've already visited that one. If you already visited, then you don't add it. You have 0. There's no more child. Then you go to 1 because 0 is already there. You clear all the childs. So, and then 2 will go first because you're finishing all the children. Once all the children is cleared, 2 has no children, so basically goes back up the stack, and then you have 3, and then it's like a post order type of DFS. So if you haven't seen DFS before, let's try to create some function. Okay, first we need to create some adjacency matrix from this. So how do you do that? Have a hash map that points to your integer. Let's forget it. Range. I'll just do it like this. Okay, so you have the 0 index. Okay, you could do the value here, v0 and v1. What you want is you want to store b. This is the ADJ. Then assign that to v0. right? Yeah. So there you have it. You have your adjacency matrix here. So let's create the DFS function. So we have our your current node in your adjacency matrix, which is this one. And then our result map, where we store our result. I'm gonna use a pointer here. Just put an array. Is it like this? Let's try. Okay, not this one. So basically, we first find all the children for root. So this is an array for I. Yeah, just all the childs. So this is our child now. Then we have to call this again, like this is a recursion, where you pass the child here, and then okay, then you pass your res. Var state map, or it's just a map of int. Just to track all the state here. Okay. Let's just assign this thing here. And so state your node assigned to 1. Okay, let's put some variable. 1 means visited, 0 means the default, which is not yet visited, and then 2 means done. Okay, which means it's already been processed. So done happens here at the bottom, like after we did this for loop, state root assigned to 2, and there should be a check, like if state root is equal to 1, means it has been visited before, else then it's a cyclic, right? So if it's a cyclic, we should create another variable here, var cyclic. Cyclic equals true, because it's we found that it's already. So if it's cyclic, you immediately exit, because there's no point of processing it. Return. Okay, after that, so we have to go through each of the number of courses. For I equals 0, I is less than num course, comma I plus plus, then you call DFS DJ. Okay, we need to pass a res result object, and var res should be yeah, really here. Append. We have to check. Not equal to 2 means it's not, you don't have the duplicate there. So we assign it to 2, and then we assign the append it to the result. Result is just an array of int. There's nothing really here. And then we return this func reverse. return S, and just return reverse. So res. That's the ampersand. Number 2. I think you could do something like this, right? You can also use make. Okay, forgot the int here. Defined root. Okay. $34 undefined root. Okay, let's try again. Should assign it here. Was false. I don't know if they can be nil. Don't even need this. Can range over ADJ root 36. Okay. Actually, it's a list. It's a adjacency matrix, so it's a list of yeah. ADJ is actually a hash map of array of. Should be append. It's actually a not too easy problem. Okay, immediately it exits the DFS. Okay. Okay, I think this should be in here. If, then this should be else if. If it's it should be this one. It's not yet done. We go in here. Okay, we have an extra 1. That's the problem. Why there's an extra 1 at the back? So 1 0 we got. I think when on the second loop, the 1 comes on the second loop where. Okay, this is wrong. It should be so we're traversing the child, not the root. Can we put some print here? Okay. Okay, so I think we should add this one also here so that it doesn't go here again. Okay, good. Okay, now we have a cyclic is failing. Okay, this is wrong. So when this is like state is still normal, is 0 for this. Okay. Just force it down if it's C. C means there's a cyclic, it's not possible. Okay. I think you can make this faster without using a reverse, but you have to do a prepend instead of a pen. Yeah, and so that's it. That's how you solve this problem. Basically, you use a DFS, but you have to use a post order where you append the nodes after you process all the child. So this is just the way you child it and then you append it at the back. So if you like this video, hit like and subscribe. Thank you for watching, and I hope the quality will be much better from the first video.